All right, good morning, young people. This is Mr. Williams. I am here today on October the 8th, 2019, and I'm going to be making a quick video for you dealing with circles, circular motion, angles, things of that nature. So, I don't know, that looks kind of light. Let me get a pen. Give me just 1 second. Yeah, that looks better. Okay, I'm going to recap some things I told you the other day in class. So the short story is the Sumerians. They were an ancient people. They're one of the first human civilizations that had writing and architecture and things like that. They lived between the Tigris and the Euphrates River in what is now modern-day Iraq. So the people were called the Sumerians, and they lived in the city-states of Ur. So they were a peculiar people. You all think that counting by 10 is normal because you have 1, 2, 3, 4, 5, 6, 7, 8, 10. You have 10 fingers and toes, and you probably think that that's normal. But it turns out that a lot of human civilizations do not count this way, and the Sumerians did not count that way. The Sumerians used their thumb as a pointer, and they counted by 12. So they counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And in English, we would call 12 a gross. So then it would be gross 1, gross 2, gross 3, gross 4, gross 5, gross 6, gross 7, gross 8, gross 9, gross 10, gross 11, gross. Then that's 2 gross. And then 2 gross 1, 2 gross 2, 2 gross 3. That's how they counted. That's called a base 12 system. Their basic number was 12, not 10. So I know that you probably think that base 10 is the only way that it could possibly be because everyone in the world right now does everything in base 10, but the Sumerians did not. The Sumerians, the reason we are talking about them in this class is it turns out that if you're the first person to do something, your decisions have an outsized influence on everyone who comes after you. And since the Sumerians counted by 12s, the effect of that decision of counting by 12s reverberates all the way down to the present day. The Sumerians believed that their gods were from the sky. The Sumerians built unusual architecture. So they built these special temples to their gods. They looked like tiered wedding cakes, like this. I'm only going to do a 3-tier one because I can't really go any higher. And up here at the very top is where their high priests worshiped their gods. Buildings like this were called ziggurats. Ziggurats. This would be a ziggurat. And the high priest would lay flat on his back at the top of the ziggurat at night and look at the stars because the Sumerians believed that the stars were the way that their divine beings communicated with them. So worshiping their gods involved looking at the sky and trying to determine what message the Sumerians' gods were giving to the Sumerian people. The reason we care is the Sumerians recorded the messages from their gods, or to put it in scientific speak from today, the Sumerians recorded carefully the location of everything in the night sky, all the stars. This is really cool stuff. If you're interested, the earliest known supernova was recorded by a Sumerian priest. These people, I think they lived, I don't know, about 5,500 years ago, maybe 5.5, 6, somewhere along in there. These are truly ancient peoples, and their records have persisted down to the modern day. So modern scientists still look back at the Sumerian records of the sky. So if you are a Sumerian priest, you're lying on the top of your ziggurat, it's nighttime, you see all the stars above you, and your task is to record where the stars are, that's a difficult task. So if you're lying on your back at the top of a cigarette looking at the sky looks like a circle. So you look up, you're looking straight up, here's the sky, and you have to plot where all the stars are. Well, the Sumerians count by 12s. I already told you that. So they divided the night sky into 12 even sections. So this is going to be a little hard for me. Let's do 6 first. So 3 on the top, 3 on the bottom. As you all know, I can't draw very well. And then I'm going to cut each of those in half. So the Sumerians had 12 quadrants of the sky, or 12 parts of the sky. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 was the most important number to them, just like 10 is to us. So everything was related to 12. So for us, counting by 10, important numbers are 5 and 2, because you can multiply 2 times 5 to get 10, and that's an important number. For the Sumerians, important numbers were 3 and 4, and 2 and 6. So 3 is important because 3 times 4 gives you 12. And 6 and 2 are important because 6 times 2 give you 12. So those numbers were important to them in the same way that 5 and 2 would be important to us for the same reasons. For the first couple of generations that the Sumerians were keeping track of the sky, they would plot where the stars were in these quadrants, and that worked for them. But then the priests began to demand more accurate locations of the stars at night as their culture grew. So then the Sumerians further subdivided the 12 sections of the sky, and they divided each section. They couldn't do it by 12 again. If they had it would have been 12 by 12, which is 144 sections of the sky. But they were limited by the technology they had at the time. They were not able to. They didn't have paper. Papyrus had not yet been invented by the Egyptians. That came much later. They were pressing. They basically took clay from the banks of the Tigris and Euphrates River. They put them in small little boxes, and they used reeds to mark. They would mark out their circle, and then they would mark in the mud where all the things they saw were. So they couldn't get too refined. They couldn't do 12. And since they couldn't do 12, they went with the lowest number that was special to them, which is 3. And so they divided each one of the 12 sections into 3. And I am not an artist, so this is not all perfect, but this is as good as I can get right now. And I think this is good enough for you to get the idea. Clearly, I can't draw well enough to be a Sumerian priest, so they would probably chop my head off if I were alive back then trying to be a priest. So let's see how many sections of the sky we have now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 1, 2, 3, 4, through 5, 36. Now they had 36 sections of the sky. And for the rest of the Sumerian the lifetime of the Sumerian civilization, they divided the sky into 36 sections. So the Sumerians divided the sky into 36 sections. And they would say, at 2 hours past sunset, the star Antares was here. And then at 8 hours past sunset, the star Antares was here. And they would just record, because if you ever look at the night sky, the stars move over the course of the night. So they would record at different hours where all the stars were that they could see. And sometimes they observed all kinds of interesting phenomena, meteors, meteorites. They didn't usually record the meteorites, but they would record meteors, and they would record asteroids that flew too close, comets. They would record supernova that they saw from distant galaxies. Of course, they didn't think that was what caused it. They thought it was their gods talking to them, but whatever. They were a primitive people, and that's what they believed. Now, this information was passed down. The Sumerian civilization was lost and overrun by successive empires, and humans became they developed more and more complicated civilizations. And one of the successor civilizations to the Sumerians, many thousands of years later, were the Greeks. And the Greeks had all this information that the Sumerians had retained, and they didn't like the way the Sumerians had cut up the sky, so they came up with a different way, which we're going to talk about in a second. But they did record and preserve the Sumerian records, and they passed them on to a civilization that came along at the end of their civilization. So as the Greek civilization began to lose prominence around the Mediterranean, the Roman civilization grew up on the adjacent peninsula. Across from the Balkans, you had on the Italian peninsula, the Romans began to take precedence. The Romans did not count by 12. The Romans counted by 10. Now, the Romans felt that everyone who came before them, except for the Greeks, were a bunch of barbarians. The Romans were very snooty. They thought they were the best that had ever been and would ever be, and they felt that the fact that they had conquered the entire known world proved the superiority of themselves, their gods, and everything about their culture, including the way that they counted. Romans really were full of themselves. Now, the Romans counted by 10. They looked down on the Sumerians for counting by 12 because clearly that was a sign of an inferior civilization. If it hadn't been inferior, it would still be here. That was the Roman way of looking at things because they were jerks. The Romans wanted to prove their superiority to those ancient Sumerians who everyone else looked up to, and they said, we can cut the sky into more subdivisions than the Sumerians, and we can get more accurate sky maps, and thus we will prove that we and our gods are superior to the Sumerians. So the Romans took the 36 sections of the sky. They had better technology now. They had papyrus, they had paper, and the Romans were able to make great big rolls of paper that extended for big distances. They weren't committed to just tiny little boxes of mud, and so they could spread out more, and because they could spread out the more, they cut the sky into more sections. They took every one of the Sumerian sections and they cut each one of them into 10. So the 36 divisions that the Sumerians had, the Romans divided each one of the Sumerian sections into 10 little subsections. So the Romans had 360 sections of the sky. So people often ask me, why are there 360 degrees in a circle? Well, it's actually an old story. It's a story as old as human civilization. It has to do with the Sumerians counting by 12, dividing the sky up by 12, then refining that number and dividing each of their 12 sections into 3. And then the Romans coming along many thousands of years later and saying, hey, we're better than the Sumerians, and dividing every one of the Sumerian sections by 10. We today call each one of those little wedges of the sky a degree. Each section of a circle divided in this way is called a degree. So there are 360 degrees in a circle. Now, there is another part to this story. The Greeks didn't like either one of these solutions. The Greeks felt that the number 12 was arbitrary and the number 10 was arbitrary. And there's no particular reason why you should count by 12 or 10 or 6 or 9. They felt that whatever choice you made was arbitrary and thus a human invention. The Greeks were interested in godly perfection. They felt that the gods existed in the sky the same way the Sumerians did, and they, well, mostly they lived on top of Mount Olympus, but they were high above us. And the Greeks felt that perfection was what they should be looking for. So the Greeks took the circle and they said, the circle is perfect. It has no beginning. It has no end. This was part of their mystical cult beliefs. They had the Dionysian cult, the Apollonian cult, the Athenian cult. They had these specialized religious, it's kind of like religion. Christianity is divided into lots of different sub-beliefs, like Catholicism and Protestants and Baptists and Methodists. There's all kinds of different beliefs. The Greeks, they all believed in Zeus and Hera and all of their gods, but they had these little divisions in their religion. They were called cults. They had different cults devoted to different gods, and all of the cults were fascinated by the perfection of circles. So circles are really big to Greek religious thought and Greek cultural life. And the Greeks said anything dealing with a circle needs to refer only to a circle because the circle is perfect, but humans aren't. That was part of their religious stuff. So they were able to measure certain aspects of a circle with the tools they had at hand. And the only tools they had at hand were string, and basically what you might call a ruler, but they didn't have a ruler the way we think of it today, but they basically had string and a ruler. So they could take a piece of rope or string and they could lay it down around the outside edge of a circle, and they could also lay it across the middle of a circle, and they could measure that. And the Greeks found that if you take this length of rope, the length of rope that goes through the center of the circle from edge to edge, that is called the diameter. If you take the diameter and you divide the diameter by how much rope it takes to go all the way around the circle. So if we would take this, it would be about here, and then this, about here, and this, about here. So if I were to take the diameter of rope, lay it out, I would get about like, it would go this far. So if I took the diameter and I began laying it around this edge. So if I took the diameter and divided by the circumference, CIR, I cannot spell, CUMFERENCE. I don't know. I'm not a speller. I'm a physics teacher. So if you take the diameter and you divide it by the circumference. So another way to think about that is if you took the diameter and like this length of rope and you started laying it around, it would lay out 1, 2, 3, and a little bit. They found that it was about 22 sevenths. So that's 3 1/7 more. So the Greeks found that if you took the diameter and you laid it around the circumference of a circle, it would go around 3 1/7 times. So they felt this number was very special, and so they called this number, we call it pi. So pi, and it's about equal to 22/7, which is about 3 and a little bit, so 3.1, something like that. It's about 3.1. Pi is just the Greek symbol, lowercase p. So there's nothing special about the symbol. They could have chosen X, but they chose P. So P is 22/7, which is 3.14. And the Greeks said, okay, that's cool. Now, we don't think we should talk about where something is inside of the circle that is the sky with reference to numbers that we arbitrarily choose. We should use only things that are inside the circle. So the Greeks said, well, look here. The radius is inside the circle, and that's half of the diameter. So if I take the radius and I could lay it out like this, just like I did with the diameter, but if I were to curl that radius around, so if this is a piece of string and I laid it out flat like this and then I curled it around the edge, then the angle that the wedge that I make here, this little wedge, that is the basic unit for the Greeks. And they made it using a radius, so they called it not a degree, but a radian. And the Greeks found that if you take this, you're going to get 1, 2, 3. Oh my God, you get 3 in a little bit. So to go halfway around the circle, you get pi radians. Oh my gosh, that's crazy. So to go halfway around the circle, you get 1, 2, 3, and 1/7 of a radian. You get 22/7 of a radian when you go around a circle. So there are pi radians in, now for the Romans, how many degrees did they have? If you'd gone halfway around the circle, all the way around was 360, so half was 180. So pi radians is 180 degrees. If you continued, but I'm going to go this way around the circle just for ease. So it'll be 1. That is not drawn well, but this would be 1, 2, 3. This would be pi radians the other way. So how much is it all together? Well, it's 1, 2, 3, 4, 5, 6, and 6. That's 6 radians plus 2/7 of a radian, or it's 2 pi radians is equal to 360 degrees. Okay, that is a brief overview of where we get some of this stuff from. Now, let's see how we use it. 1 revolution, dance revolution, means that you were to go around a circle 1 time, or 1 rotation means that you go around a circle 1 time. Revolution, rotation. That is the same. 1 rotation is 1 revolution is 2 pi radians, which mathematicians and physicists just write rad because radians are rad, or 360 degrees. These all describe what happens when you go around a circle 1 time. They can also be used to describe how far you've gone around a circle. If you've only gone part of a revolution or part of a rotation or part of 2 pi radians or part of 360 degrees. Okay, I will do more practice with you in class, but this is the basic gist. I guess I should do one example. I'll do one brief example because I have a couple minutes and then we're going to move on. Let's say that you saw a star in the night sky, and it was in the, as you went around, it was in the 92nd degree. And you wanted, so that's the Roman way of measuring it. You wanted to find out how many radians it was. All right, 92 degrees. I need to multiply by some fraction that is 1. And I want to have degrees in the bottom, and I want to have radians in the top because radians is what I want it to be. And I want degrees to cancel out. So what is my relationship between radians and degrees? Well, I know that 360 degrees is the same thing as 2 pi radians. So then, if I say 92 times 2 times pi divided by 360. That's 1.6 radians. Let's think about that logically. Where would 92 degrees be here? Well, 90 is straight up, right? So let me get a different color. 90 is straight up, a 90-degree angle. This would be a 90-degree angle right here. So 92 would be off like right here somewhere. And where is that in radians? This is 1 radian, this is 2 radians. So a half radian would be like right here, and this is saying 1.6 radians. Is that logical? Yes, it is. So that's an example. All right, that's all I've got for today. Have a wonderful day.